Hello everyone, thank you for joining my session. In the next 35 minutes, I'm going to tell you everything you need to know about the different options we have to host our agents in Azure DevOps. This session is geared more towards beginner, therefore I'm going to start with an introduction what Azure DevOps agents are and why we need them. But even if you're experienced, it might be interesting for you because in the end I'm going to talk about Azure Managed DevOps Pools, which is one of the best services on Azure right now and probably a game changer how we manage our agents in Azure. Before I get started, a couple sentences about myself. My name is Wolfgang Ofner. I'm a freelance cloud architect based in Toronto, Canada, and I focus on Azure, especially on architecture, security, and governance, as well as Kubernetes and DevOps. If you have any questions or want to stay in touch with me, feel free to reach out on LinkedIn. And if you're interested in more DevOps and Azure topics, I started a YouTube channel this year and I post a new video every week. Now let's get started with Azure DevOps. So the first question is why we need an agent in Azure DevOps and what this agent can do for us. The main reason why we have an agent is we want to have a piece of software that can execute code. This could be the same steps you do on your build machine. For example, build a project, execute unit tests, and so on. But it can do way more. It can execute all kinds of scripts. For example, run integration tests, UI tests, but it can also deploy code, do some health checks. So the options are basically limitless. Our agents have software installed. That's the software we need to build our applications and to deploy them. For example, if you have a .NET application, then you have the .NET SDK installed on this agent. I just said that an agent can do basically anything like building our application and deploying it. And the reason why we want to do this is we want to have automation. Our systems are becoming more and more complex, and it's going to be way too much work for a developer to deploy it into all the environments with all the different steps we have. And therefore we want to automate it. Another reason why we want to automate it is it's reproducible. So if I run my pipeline and then I run it again, it runs exactly the same way. As a developer, I might forget a step and then something is not working and I have to figure out why it's not working. Another reason why I want to automate everything is I can scale this. So if I have 100 developers in my team, they don't have to do all the same tasks when they want to deploy a new feature. So they just let an agent run the deployment script and the agent can scale out. So if one agent is not enough, I can just add more agents and build and deploy my applications. Then what's important, especially from a security perspective and when you want to know what's going on, is you want to have audit logs. So I want to know who deployed which piece of software and where, and also when. If a developer just deploys it over the Azure portal or through an IDE, I don't know who did what. And with a pipeline, I know exactly when the pipeline ran, what it did. And if something goes wrong, I can check in the pipeline and I can figure out what happened easier. So now we know the basics about agents. Now I want to talk about the different kinds of agents we have. First, we have the Microsoft hosted agents. I'm going to talk about the self-hosted agents. As the name suggests, the Microsoft hosted agents are managed by Microsoft. This means Microsoft takes care of everything. So if there's a new version of an agent, Microsoft updates the agent. The same as if there's a new version, for example, for .NET, then Microsoft installs the new version of .NET and makes sure everything works as I want it. Microsoft offers agents that are running on Ubuntu, Windows, and macOS. The big advantage for me is that I can just pick the agent I need and I don't have to figure out how to install and configure them. This makes it very easy for developers to get started. For example, if I'm a Windows developer and I need an Ubuntu agent, I can just pick it. And here in the screenshot, we see the configuration. So here we have a sample pipeline, and inside this pipeline, I can configure a pool, and inside this pool, I can configure the VM image. And in this case, we use Ubuntu latest, And this tells Microsoft to give me an Ubuntu agent with the newest version. And the same for macOS and Windows. So that's all I have to do. Then I can run my pipeline and the agent takes care of everything. In this case, I'm using the latest version of the agent, but I can also specify the version. For example, Ubuntu 22.04 or 24.04. Then all these agents come with pre-installed software. You can see on GitHub which software they have installed, but it's like all the common programming languages like PHP, .NET, Java, then also some build tools like PowerShell and so on. But also if the software you need is not installed, you could also just install it via script and have the software on the agent. Then the main reason probably why you want to use this is first to get started. It's very easy to just pick the agent and it runs the software or the tasks for you. And it can also be very cost effective. We're going to talk about the costs on the next slide, but you get a free tier. And if you just want to try it out, you won't run into any costs. As with everything, there are not just upsides, there are also downsides. And so the Microsoft hosted agents come with some limitations. The first limitation is every time you run a new pipeline job, you get a new agent. The problem with this is that you can't do any caching. So for example, if you have a Docker image and you build a Docker image, the first time it takes a long time, but the second time you build it, you can reuse everything that hasn't changed because it's cached, so it's very fast. But with the Microsoft hosted agent, you have to rebuild it every time. Then another disadvantage is the pre-installed software. Before I said it's an advantage to have the software already installed, but it can also be a disadvantage because if the software you have is not installed and you can't install it via script, like for example, a PowerShell script, then you can't just use the Microsoft hosted agent. Then also the agents come with very limited resources. Again, if you just want to get started with Azure DevOps, try something out, it's enough, but the agent comes with 2 CPU cores and 7 GB of RAM. It might be enough if you want to deploy software, for example, just execute some scripts. But if you want to build your software, it might be not enough. Then when it comes to security perspective, a big downside is that you can't integrate the agent inside your own network. So for example, if you have software on premise, the hosted agent always runs on the internet and has to connect over the internet to your on-premise network. The same if you have VNets on Azure. The Microsoft hosted agent has to connect over a public IP address to your services, and therefore they have to be available on the internet. From a security perspective, we don't want to have our services available from the internet often. For example, a database or an Azure Key Vault should be only available from a private network, and then we can't use the Microsoft hosted agent to do the deployments for these services. Therefore, we need another solution, and that's something we're going to talk about at the later stage of this presentation. The last limitation we have with the Microsoft hosted agent is the execution time. So if you have a public project or a paid agent, you can run your agent for up to 6 hours. And if you have a private project or an unpaid agent, then you can only run your agent for 1 hour. After 1 hour, the agent will just stop and your pipeline will fail if it's still running. This also leads us to the costs of the Microsoft hosted agent. So as I said before, you get a free tier. That's one agent with 1,800 minutes per month that are always free, and you can use them to do whatever you want. Additionally, Microsoft is trying to support open source and public projects, and therefore you get 10 agents for free if your project is publicly available. If that's not enough, then you can buy additional agents. And to be more specific, in Azure DevOps, you buy parallel jobs. And with these parallel jobs, you also get an agent. And that's also a downside or a limitation of Azure DevOps. So the license restricts how many parallel jobs you can have. So even if you have 10 agents, but only 2 parallel jobs, then you can only run 2 agents at a time. This means if the one agent is not enough, then you have to buy an additional one, and this costs $30 per month per parallel job. Now that we've talked about Microsoft hosted agents, I want to move over to the self-hosted agents. And they are a bit like the opposite. Before I said Microsoft manages everything, and with the self-hosted agent, as the name again suggests, is we have full control over the agent. This means we can install any software we want. So this can be non-supported software from Microsoft. It could be a bit of an exotic software, also software that needs a UI. I can install whatever I want. I have full control over it. I can also use any hardware I want. So I could install it on my development machine if I want to try something out, or I can have the most powerful servers and run my builds there. Also with self-hosted agents, I don't have the limit of the execution time. This means my agent can run as long as the pipeline needs. That's especially useful if you have a very big project or you run tests overnight and you don't want to run into any limitations. Another advantage is that you can easily integrate the agent in your networks. This could be on-premise or in the cloud. And then you can use the agent to deploy over a private connection to all the services you need to. The self-hosted agents are also available for Ubuntu, Windows, and macOS. Like the Microsoft hosted agents, self-hosted agents also come with limitations. Since you're responsible for everything, this means you're also responsible for the maintenance. This means you have to update the agent, update the software that's installed on the agent, update the infrastructure. For example, if you're running on VMs, you have to update them. And you also have to pay for the whole infrastructure. Again, you have to pay for the VM, the networking, everything you need to run your agent. Another responsibility you have is to manage the scaling of the agents. So you can install one agent, but if this agent is not enough, then there's no process to add more agents. You have to take care that there's a process in place to add more, but also if the agents are not needed, to scale down and not use up all the resources you have. This also means you have to have some monitoring in place. Some agents fail. If there's something going on, you want to know about it, and you also manage the resources. So if you are, for example, VMs are running out of CPU or memory, then you have to take care of it. There's no Microsoft help. The costs, it's similar like the hosted agent. In this case, you get one free parallel job per Azure DevOps organization. And you also get one parallel job per Visual Studio Enterprise license. That's the same as with the Microsoft hosted agents, but since you don't get an additional agent with the Visual Studio Enterprise license, I haven't included it there. Since you're running the agent on your own hardware, the agents are a bit cheaper, and so you pay $15 per month per parallel job for self-hosted agents. But you have to factor in the infrastructure cost. And if you have many VMs or powerful VMs, it can get quite expensive. And you also have to factor in the maintenance cost, like the manpower and man time for all the maintenance and configurations. Now let's take a look at the different options we have to host our agents. First one, we're going to start with VMs. Hosting the agents on VMs is the go-to solution. Like if I talk to any teams, they say they need a self-hosted agent. The first thing that comes to mind is VMs, because that's the way we did it in the last 20 years. That's the way Microsoft did it. And it's kind of easy to do, but I'm going to show you later on a better way how we can do this. The reason why VMs are so popular is that we have full control over the infrastructure. This means I can pick the operating system I need, I can pick the network configuration, I can install any software I need, I can do literally everything I want. Then it also allows for caching. Because I have my agent running on my VM, I can reuse the same agent over and over again. So I can cache like Docker files, images, any artifacts I need for the build, and this can speed up the build tremendously. Also, since I have full control over the VM, I can easily integrate it in all the networks I need it. This can again be on-premise or in the cloud. I said before that you have to take care of the scaling. So if the one agent is running out of resources, you want to add more agents. And in Azure, we can use virtual machine scale sets. That's basically a copy of your VM. So if the first VM runs out of resources, Azure can automatically add more VMs and also can implement some load balancing. But you also pay for the additional VMs. Then the downside, as said before, is you have to take care of the VMs, of the software that's installed, of the agents to update, the networking. If something is going wrong, you are responsible to figure out what the problem is. Then also, VMs are really expensive and the VMs are often underutilized. This means if you work from 9 to 5, they might be used maybe for 80% fairly regularly, but then from 5 to 9, there are barely any usage, but you still pay the full price for the VMs. Obviously, you can scale down, but it again needs work and still you have to pay for it. The last thing to keep in mind is how can you securely access the VMs? If you have VMs, Microsoft recommends to use Azure Bastion. Azure Bastion is a jump host, and the way it works, you connect to this jump host and then you connect over a private connection to the VM. That's a great solution. It's very secure, but you need someone who can set it up, who can troubleshoot if there are problems, and you also have to pay for the service. So again, it makes running your agents more expensive. And this leads to an alternative. You could also run your agents in a container. The big advantage of this is that you can also install all the software you need with the Docker file. So if you take a look at the Docker file, here we use as a base Ubuntu 24.4. Then we install every piece of software we need. For example, we install Git and curl, and down here we install the .NET 9 SDK, and we also install Podman, so we can build container images with this container. Using the agent in a container is very easy for local testing because you only have to run the container and everything is already configured inside this container. You don't have to figure out how to install the agent or connect it to your Azure DevOps environment. In a production environment, you often use Azure Kubernetes Service or the Azure Container Apps to run your container. And then you use KEDA, the Kubernetes event-driven architecture, to scale the pods or the containers of your agent. And the big advantage of KEDA is that you can also scale them to 0. This means if no agent is needed, you don't have any software running. Therefore, you don't need any resources. This leads that you can often run your container with a minimal cost, especially if you have already an existing Kubernetes cluster and the cluster is not fully utilized. Also with Azure Container Apps, you have a free tier, and if you don't need too many resources, it might be already enough for you, or the costs are very limited. The downside of running your agent in containers is that you have to know how containers work. This means you have to know how to create a Docker file, how to install software in the Docker file, and if something is going wrong, how to troubleshoot it. Another downside or kind of problem is how to build a Docker image with your container. That's called Docker and Docker. And that's not possible for security reasons in Azure Container Apps. And in AKS, it's only possible if you give the container more permissions than you would like to. A bit of a workaround is to use Podman instead of Docker, but it still comes with security problems. And another solution could be Canico. That's a piece of open source software that allows you to build your Docker images in Kubernetes. But again, it can be quite complicated and is not as easy as the other options we have seen so far. If you only use Kubernetes, then it also might be a too complicated of a solution, because with Kubernetes, we can already use GitOps. GitOps simplified is using an agent that's running in Kubernetes, and it pulls changes from a Git repository. So if something changed, the GitOps agent pulls down the changes and applies them. Therefore, it might be a better solution for Kubernetes only. And also, you don't have any caching. If you need a new agent, the agent is created, and after the agent is not needed anymore, the container is deleted. All these downsides lead us to the last service I want to show you today, and that's Managed DevOps Pools. That's one of my most favorite services on Azure right now, and I think it's a game changer on how we can host our agents. Using Managed DevOps Pools provides all the advantages of having your agent installed a VM without the downsides. The way it works is that Microsoft creates the VM, also manages the VM for you, and then installs the agent on the VM and connects the agent to your Azure DevOps organization. You don't have to manage anything. Microsoft provides agents for Windows and for Linux. Since you can't run Mac OS VMs on Azure, you can't have an agent for that. And if that's not enough, then you can create your custom image. This might be useful if you have software that's not provided by the Microsoft hosted agents. So you can create a VM yourself, install all the software you need, then you create the custom image, and when you create the Managed DevOps pool, you just provide this custom image. You don't have to install an agent or configure an agent. This is all done by Microsoft once they create the Managed DevOps pool. Another advantage is that you can easily integrate your agent with an Azure VNet. This allows you to do deployments for resources that are not available over the internet. The deployments are done via private connection, and this enables you to keep them private. This makes sense for sensitive data, for example, an Azure Key Vault databases, so you don't want the internet to have access, but with this approach, you can still do your deployments. I think I already said it a couple times, but this is by far the best option we have for self-hosted agents in my opinion. Managed DevOps pools come with all the advantages of using VMs without any of the downsides, and also the costs are very limited, as we will see on the next slide. One minor downside might be that Managed DevOps pool went GA in November 2024, and if you have been using new Azure services before, you might know that they often have some teething problems. So for example, I found a breaking bug in January, and this bug prevented many tenants worldwide to create a Managed DevOps pools. But Microsoft fixed the bug by now, and they also fixed a couple others I found. So it's been like 7 or 8 months since the service GA, so I think there shouldn't be any reason why you can't use it. Another advantage, as I said, the costs. If I have an agent in a Managed DevOps pool, I only pay for the VMs of this pool when the agent is running. This is great from a cost perspective, but it also comes with two downsides. The first downside is I get a new agent every time I run a new pipeline. Therefore, again, I can't do any caching. And it also takes around 3 minutes for the agent to be created. Microsoft says it can take up to 15 minutes, but in my experience, it's always around 2.5 to 3 minutes. The big advantage of this approach, though, is that we can use very powerful VMs that cost barely anything. An example would be one of my teams has been using the Microsoft hosted agents before to build an Ubuntu image, and this took 1 hour and 10 minutes. Now we switch to the Managed DevOps pools, and we're using a VM with, I think, 48 CPU cores and a couple 100 GB of RAM, so way more than enough. And now it takes 7 minutes. And we only pay for this 7 minutes. This means the VM costs, I think, $4 per hour, but for the 7 minutes, that's a bit more than 60 cents. And we sped up the pipeline by more than an hour. So the developers don't have to wait forever for the feedback, and they can get back to it very quickly. A workaround would be to use standby agents. This means you already have one agent provisioned and the agent is waiting to execute the pipeline. Since the agent is already running, you don't have a startup time, but you pay for the time the agent is running. If you're interested in this, I made a YouTube video about how you can optimize all of this. So my idea would be to create a new agent for the first time you run your pipeline, and then you have the agent for a couple minutes on standby. So if you run several pipelines after each other, you can reuse the agent. But if there's nothing coming for like 3 or 5 minutes, then you delete the agent. The advantage is you can use caching, the same agent, you don't have to wait, but you only pay for a couple additional minutes of the agent. Also, when you use VMs, you have to take care of the scaling yourself. There are Azure services like the virtual machine skill set that will help you with it, but you have to configure it. With managed DevOps pools, you can just tell Microsoft how many agents you want as a maximum, and then Microsoft or Azure will take care of it. Also, since it's a new feature, a new service, they are not all features we want implemented right now, but there are new features coming out every month. For May, for example, there's planned that the startup time will be reduced. As of recording of this video, mid of May, it's not implemented yet, but it should come very soon. And you can also take a look at the roadmap that's publicly available, so you know what's coming when. We loved all of this theory. Now switch to the Azure portal and create a managed DevOps pool, and then I'm going to show you a pipeline, how you can use this managed DevOps pool, how easy and fast it is to set it up. All right, here in the Azure portal, we can search on the top for managed DevOps pools. Then we can create a new one. We provide a subscription, a resource group. Then we have to provide a dev center. The dev center takes care of all the hardware and infrastructure behind the scenes. This means every time I create a new agent, a new VM is created and the dev center takes care of this. I already created a dev center before because, as I said, there are a couple of teething problems and the Azure portal sometimes just doesn't load the dev center. If you're using CLI, like the Azure CLI or Biceps, then it's only a couple of commands and very easy to create. But for the Azure portal, sometimes you have to need this workaround. Inside the dev center, we also have to create a project. This project is linked to our managed DevOps pool, so we can create a new one. Then I just provide a very simple name like Dev Center Project. Further down, we have to provide the name of our Azure DevOps organization. So that's Programming with Wolfgang for me. And we also have to provide a pool name. This pool name will create an agent pool with this provided name. So I've already prepared a name. In this case, it's Managed DevOps Pool Demo, but you can provide any name you want. And here you can see the second problem I've encountered. In the past, when you created a Managed DevOps pool, and then you deleted it from the Azure portal before you deleted it in the Azure DevOps organization, then this pool name remained somewhere. I can't find it, it has been deleted everywhere, but it still says it is there. This problem also has been fixed by now, so you shouldn't have this problem, but I have this problem here for this demo. So I just add 2, then it should work. Then we provide the region, the maximum agents. This is how many agents can Azure create. For us, it's just the one. Then we can create the agent size. So the standard one is a fairly small VM with 2 cores and 8 GB of RAM. If you click here on change size, then we can see all the options we have for the regions I have selected. Here you can see the available ones. So I can go even bigger, like 4 CPU cores, 28 GB of RAM. But if you want to go even bigger, then you can see also the non-available ones. And I think the N is really big ones. And there you can just say request quota, And if it's being approved, then you can also use this VM for your managed DevOps pool. But for now, let's leave it as it is. Then the disk for our operating system, I always select SSD because it's faster. Then we can provide the image. That's the agent we want to use. In this case, Ubuntu 24.04. If you click on this, we can see the options we have. So the Microsoft images are Ubuntu 20 to 24, although the 20 will be retired very soon. And with Windows Server, we have 2019, 2022, and 25 is coming also in the next weeks, I think. Then we can also select any images from the marketplace. Here we have a couple different Windows images and also different Ubuntu versions. And we can also provide our own image. In this case, I don't have one. Again, if that's interesting to you, how to create it, I also have a YouTube video about this on my channel. For now, again, we leave it as it is. Then here with the scaling options, we can decide if we want a fresh agent and we only pay for the agent while it's running, or we want to reuse the agent we already have, but then we have to pay for it. Also with the standby, we can decide if you want to don't have any standby agents, therefore you don't pay for it, or we can say we want to configure it manually, for example, from 9 to 5, or we can let Microsoft decide. So Microsoft will try to figure out what is the usage you have and then scale accordingly. For now, just keep it as simple as possible. Next up with the networking. Right now, I don't add my managed DevOps pool to any network, but you can add it to any existing virtual network. Then you can attach more storage. This would be an Azure storage account if you need more storage than the VM has. Then the next tab, there you can configure if you want to add this managed DevOps pool to one organization or to many organizations. And inside these organizations to one project or to all the projects or multiple projects. And also this feature down here, that's new. Usually when you have a new agent pool and you run a pipeline for the first time, then you have to approve it. If you select this option here, you don't have to approve it. But I'm not going to show you, I'm not going to select it because I want to show you how to approve it later. Then we have the tags and then we can create it. So that's everything we have to do. With this, let's create it. It should take only around 2, maybe 3 minutes. And once the managed DevOps pool is created, I will be back and we go to the Azure DevOps organization and run a pipeline there. The managed DevOps pool is created, and before we switch to the Azure DevOps pipeline, let's take a quick look at the managed DevOps pool here in the portal. There you can see everything we configured when we created, so you can also change it afterwards. For example, we can change how many agents we have, the agent size. What's also interesting is the identity here. I haven't talked about this before, but here we can assign an identity to our agent, and then we can easily use this identity to access other Azure services. For example, this identity could have the permission to read secrets from the key vault, and then we can read, then our agent can read the secrets from the key vault. With this, now let's switch to Azure DevOps. So I've prepared here a pipeline. The most important part of this pipeline is this pool, that has the same name as the name we provided before for the pool. And then it's a very simple pipeline. So it has one step that's down here, and it builds a Docker image of a .NET application. So now let's run this. The first time I'm using this pool, I get here this message that the pipeline needs permissions. That's exactly what I said before. I didn't check the checkbox to give the permission already, so I have to do it here. And all I have to do is just click on permit and then click on permit again. And now the managed DevOps pool sees there's a new pipeline and it will create a new agent for me. And once the agent is ready, it will run the pipeline. This is going to take around 3 minutes, I guess. So I'm going to stop the video here and I will be back once the pipeline is finished. The pipeline failed, and after checking, I saw that I selected the wrong image for my agent. So if you switch back to the Azure portal and if you scroll down under the pool section, there you can see I selected the Ubuntu server image. I don't know why I didn't select a pipeline agent by default. But again, that's the teething problems I've been talking about, and if you use infrastructure as code, you don't run into this problem. So for now, I'm going to delete this image. I select a new one, and this time I select Azure Pipelines Ubuntu. Then I apply this. This should only take a couple seconds, and then we switch back to the Azure DevOps organization and restart the pipeline. The Managed DevOps pool has been updated, so let's switch to the pipeline and just execute or rerun the pipeline. This again will create a new agent, which will take a couple minutes, and hopefully the pipeline runs successfully now. And if so, I will come back after it is finished. With the right image selected, the pipeline now finished successfully. What's interesting though is that it took 6 minutes to create the agent. I said before, usually it's around 3 minutes, but here in this example, you can see sometimes it takes a bit longer. This brings us to the end of my presentation. To quickly recap what we talked about today is, first, we talked about Azure DevOps agents, why we need them, how to execute our software, run scripts, and do everything we need them to do. Then we took a look at the different options we have. First, the Microsoft hosted agents, where Microsoft takes care of everything. It is simple, easy, but comes with some limitations. On the other side, we have the self-hosted agents, which are a bit more complicated because we have to set up everything. On the other side, we have full control over it. And then we looked at different hosting options, where I think that by far best is Managed DevOps pool. And in my opinion, it's a game changer. So if you start a new project, I would definitely look into Managed DevOps pool because I think it's the go-to solution. If you're interested in the slides of the presentation from today, you can scan this QR code. And if you want to reach out with me, you can reach me on LinkedIn, or you can also follow me on my YouTube channel if you're interested in more topics about Azure, DevOps, and also Managed DevOps pools. With this, I hope you enjoyed the session and hopefully see you next year again.